Sad to say that there is a chance that this might be the last of the help videos for 4-12. Can't say for sure. We'll soon find out if this is the last of the videos. As we pick up with problem number 8, we are asked to do the cobalt ion 3 plus. Before we do the cobalt ion 3 plus, it will help for us to just simply do cobalt 27. Plus means that there are going to be 3 more protons than electrons. So if it has 27 positive protons, when we're done, we should only have 24 electrons remaining. There's 3 more positives protons than electrons. It starts with 27 electrons. 3 less would be 24. So let's find cobalt on the periodic table of elements, especially this one right here. Cobalt's number 27. Above cobalt, we have an S2D7. So that tells us right away that this should end in an S2D7 when we do the cobalt atom. What D7? Well, it looks like it's in the 3D, so it should be 3D7. What S? It's on the row of the 4S, so it should be 4S2, 3D7. So we can come right on here and write 4S2, 3D7, and now we just have to backfill in the inner kernel. We go to square one and work everything from square one till we get to cobalt. So here's cobalt, and we're just going to fill in everything along the way till we get to cobalt. So we start with the 1s. There's the 1s. We put 2 elements in the 1s. Hydrogen and helium, there's 2 elements there. So it'd be 1s2 right there. Now we go to the next one, the next level down. This is still the 1s2. Right here's the next level down. There's the 2s. There's 2 elements there. So we'll go 2s2. We continue to follow the numbers. 3, 4 takes us to 5 through 10. That's 6 elements. The number there is 2p. So it's 2p6. We continue down after the 2p6. Number 10 takes us to 11. 11 and 12 are the 3s. There's 2 elements there. 3s2. Follow the numbers. From 11 and 12, we go to 13 through 18. There's 6 elements there. 3p6. Now we come down to here. After 18 is 19 and 20. I'm just following the numbers till I get to cobalt 27. That's 4s. That's in the 4s. There's 2 elements there, 4s2. And now we're back to the 3D. Once again, why does the 3D get filled after the 4s? Because we do lowest energy first. The 4s has an energy of 4. Where do I get that? I add the 4. The energy is equal to the n. The n is the 4. That's the first number we see there. And I have to go to the chart to see what the energy is in the s. The energy of the s is 0. 4 plus 0 is 4. The 3D, my n is 3. That first number is the n number. The d is a code for what the sublevel is. The energy in the d is 2. So 3 and 2 is 5. 5 is bigger than 4, so it gets filled afterwards. And cobalt's the 7th one over. So we've got this right. And it matches what we predicted it should end in. Now I double check. There should be 27 electrons before I remove 3. 2 and 6 is 10, or 2 and 6 is 10, and 2 is 12. 6 is 18, 2 is 20, and 7 is 27. Very good. Total electrons match up. 3 plus. Remember, the plus sign and lost both have T's in them. So I have to pull out 3 electrons. I have to remove 3 electrons so that there's more positives, 27, than electrons. I should be left with 24. Where do we pull them out? A lot of people want to pull them out of the D first. The 3D. You're like, that's where I was. I should remove them there first. No, no, no. You remove them from the biggest energy levels first. So I remove the first 2 out of the 4s. Remember, the 4s is a higher level number. So it's actually further out than the 3D. Some teachers will actually have you do the 3D and put it inside here so that when you remove electrons, you come to that first. Well, we're going to know that we're removing them from there because we remove the valence electrons first. So we pull 2 out of the 4s. That goes to 4s0. And then the last one would come out of the 3d6. Does that help cobalt satisfy the octet rule? Well, it just lost its fourth level. So now the only level left on the outside is the third level. How many does it have in the S and P, which are the sublevels that give it stability? 2 in the S, 6 in the P, 2 and 6 is 8. Yes, cobalt could satisfy the octet rule by losing those 2 out of the S. Losing that additional one out of the D didn't really help satisfy the octet rule. So a cobalt 2 plus can still end up with the S and the P filled on the inner level. All right, cobalt. We can double check to make sure we did that right. 2, 2 and 6 is 10, and 2 is 12, and 6 is 18. 18 and 6 is 24, and that's how many cobalt 3 plus should have, 24. The next one we're supposed to do is mercury 2 plus. But before we do mercury 2 plus, we have to do mercury. Mercury is number 80. So I come over here and I find mercury. Number 80. Where is mercury? There it is. It is in the D. It is in the 5D. In fact, it's the 10th one over in the 5D. So it should end in 5D10. So right away, I can come on my thing and right here, it'll be a 5D10. What else do I know that it before I even start doing the configuration? What else would I know? It says F14. It should be an F14 right here. F14. What F14? What should be the number in front of the F? I just start backtracking. 79, 78, 77, 65, 77, 72. You can't go from 72 back to 57. You see the red line? That red line means no, you can't go back. So I drop down 72. What is before the number 72? 71. So now I'm at the 4F. How many should be in the 4F? There are 14 elements across the 4F. So mercury should be 4F14. I can go ahead and write that right on here. 4F14. So I already know it's the 10th one over in a 5D. I know it's a 4F14. So I go from 58. From 58, I now can return to 57. I can now return to 57. I've already got the 5D10 down. So what's before 57? 56 and 55. That's the 6S. There's 2 there. So even before I start, I know mercury should end in 5D10, 4F14, 6S2. But I'm going to go ahead and start at square one on the periodic table of elements and work my way to mercury to make sure I haven't made any mistakes. Here's mercury. I've got to go up to square one. That's where the race starts from on our way to mercury. Here we go. Hydrogen and helium, they're in the 1s. How many elements are there? 2. So it starts at 1s2. I proceed after that. From number 2 comes number 3. Number 3 and 4 are in the 2s. There's 2 elements there. So I write 2s2. After number 4 comes the number 5. 5 through 10 are in the 2p. There's 6 elements there. So on my thing I will write 2p6. After number 10 comes number 11. 11 and 12 are in the 3s. There's 2 elements there. So I write 3s2. After that I proceed on. After the number 12 is 13. 13 through 18. That's 6 elements. 6 elements in the 3p. So I write 3p6. After number 18, I come to number 19. Number 19 and 20 are in the 4s. There's 2 elements there, so I write 4s2. As we've said several times, after the 4s, we go back and fill the 3d. After number 20 is 21. 21 through 30 are 10 elements in the 3d. That's 3d10. After number 30 comes 31 through 36. That's the 4p. There's 6 elements in the 4p, so I write 4p6. After number 36 comes 37. 37 and 38. There's 2 elements in the 5s, so I would write 5s2. After the 5s, I just follow 38 into 39. 39 through 48 are 10 elements in the 4d, so I write 4d10. After 4d10, 48, number 49 comes after 48. I'm just following the numbers. 49 through 54 are 6 elements in the 5p. So I write 5p6. After number 54 comes number 55. 55 and 56 are in the 6s. So I would then write 6s2. I'm going to continue following the numbers. After 56 comes 57. But 72 does not come after 57. There's a little stop sign right here. The red mark says you've got to drop down and over. After 57 is 58. 58 through 71 are 14 elements. And that is the 4F as we saw. There are 14 elements in the 4F. How do I know it was 4F? It says it right there, 4F14. So I'm now at 71 and I can go back to 72. 72, right here. This is the 5D. How many elements are in the 5D? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 elements in the 5D. So I write 5D10. And just as we predicted, 6s2, 4f14, 5d10 is what we found. How do I know I did it right? I check my total electrons. Mercury should have 80. 2 and 2 and 6. 2, 2, 6 is 10, and 2 is 12, and 6 is 18, and 2 is 20, and 10 is 30. And 6 is 36, and 2 is 38, and 10 is 48, and 6 is 54, and 2 is 56, and 14 is 70. 70 and 10 is 80. We've got it correct. That is Mercury, but we are not supposed to do Mercury. We're supposed to do Mercury 2+, which we would actually call the Mercury 2 ion. I need to remove 2 electrons. 2+ means you need lost 2 electrons. I would have 80 protons and only 78 electrons. I should have 2 more positives than the negative electrons. Where do we remove them from? The valence. The valence is my biggest number. I look all the way down the line. My biggest number is 6. My biggest number is 6. So we're going to pull them from there. That's the first 2 that would go in the 2+. So I change this 2 to a 0. Does that help Mercury? Well, let's see if it left it with the stable octet. The sixth level is gone. There are no electrons left on the 6th level. So is the 5th level S and P left full? I look back. That's not the S and P, that's the 5D. It doesn't contribute much to stability. The octet comes from having 2 in the S plus 6 in the P is 8. 2 and 6 is 8. Yes, Mercury 2+, the Mercury 2 ion is left stable. In our last question, we want to do the hydrogen ion. The hydride ion would be H-. Remember, when it's a negative ion, it's gained it, and we can tell it's negative when the name is changed to an "ide" ending. But we want to do the hydrogen ion. So we find hydrogen on the periodic table. Here it is. Hydrogen is square one. We're finishing where we started every one of them. Every one of the electron configurations begin with hydrogen, and we work our way to the element. So it's only fitting we finish ending with the one we started with. Hydrogen 1 has 1 electron in the 1s. 1s1. If it becomes positive, it's going to lose that electron and become 1s0. Nothing has been highlighted here because 1s0 does not satisfy the duet rule. Hydrogen would much rather gain an electron and become 1s2. It would much rather gain one and become 1s2. S0, there is no Noet rule where no electrons is stable. Hydrogen will be looking to try to get electrons to satisfy the duet rule. And it was nice to finish where we started all of them. We have 0 left to do, the same way that hydrogen ion has 0 electrons. If you have any additional questions, don't hesitate to email me, contact me, ask me, reach out. I'm happy to help.